Hey everyone, and welcome back to the Physics 30 Unit 2 videos. In this video, we're going to be looking at two more formulas for centripetal acceleration and force. So up to this point in our videos and in our unit, we have one equation for our centripetal acceleration and one for our centripetal force, where for our centripetal acceleration, we have v squared divided by r, so your speed squared divided by your radius, and for your centripetal force, it's your mass times the speed squared divided by your period. So when we're dealing with circular motion, we can also substitute in our speed equation into our acceleration and our force equations to come up with two new ones. So here we have your centripetal acceleration, when simplified, is 4 pi squared times your radius divided by your period squared. And your centripetal force is 4 pi squared mass times your radius divided by your period squared. So if you guys want, you guys could go ahead and do the math where you take your original equations here and you're going to put in our 2 pi r divided by period in 4v into each of your equations. But simplified here, which I'm just going to give you the equation, are these two that you see right here on the screen. So once again, just like with your other equations, you want to make sure that your radius is in meters, your period is in seconds, the acceleration is in meters per seconds, and then your force will be in newtons. So we're going to take a look at example number 1 from your centripetal acceleration force section, where we're going to be doing some conversions and working with one of our equations. So here the compressor blades in a jet engine have a diameter of 42.0 centimeters and turn at 15,960 RPM. So here we're going to determine the magnitude of the centripetal acceleration at the tip of the compressor blade. So we're going to start off by, once again, writing all of our information. So here we're given that this compressor blade has a diameter of 42.0 centimeters. Remember, for any of our equations, we need our radius. So we're going to take half of our diameter, which will give us 21.0 centimeters. And because we want to have meters in our as our units, we're actually going to use unit analysis, so that there is 1 meter for every 100 centimeters. So we're essentially going to take our value and divide it by 100, so we should get 0.210 meters. And I put that 0 at the end to make sure that I'm still accounting for sig figs. So that'll help us when we get to our final answer. So next what we're going to do is we have this value. It says it turns at 15,960 RPM. RPMs are revolutions per minute, which tells us that that's the frequency. So we have a frequency of 15,960 revolutions per minute. Now this one here is very important because with our revolutions per minute, we first want to convert this into hertz, which is revolutions per second. So I'm going to use unit analysis once again to convert to revolutions per second. So I know that there's 1 minute and 60 seconds, and I want minutes to be on top here, so that way my units will cancel out when I do my unit analysis. So essentially what we're going to do is we're going to take 15,960 and divide it by 60. And this here should give you 266 revolutions per second, which is essentially our units of hertz. So now that we have our frequency, we can actually find our period for this because none of our equations gave us any information, or I guess any variables dealing with frequency, but we know that your period is equal to 1 divided by that frequency. So we can go 1 divided by 266, and we should get 0.003759 seconds per cycle, or we can just leave this as simply as seconds. And then just to make sure I keep track of my sig figs, I apologize here. Here we have 4 sig figs in as our frequency. So our actual answer for frequency should be 26 or 266.0. And so our answer for our period should go to 4 sig figs as well, which will be this 9 as a significant digit there. So there's a lot that you have to take into account with these types of questions. So I like to do my sig figs as I go through my questions, just so I don't have to go back to the very beginning and look through all my solutions again. Anyway, so now that we've found all of our information, we've written it down, and we have it in the proper units, now we can go ahead and use our centripetal acceleration equation. That is AC is equal to 4 pi squared r divided by your period squared. So here we have 4 pi squared r, and your radius, as we had calculated, was 0.210, with that 0 being significant. And then our period there was 0.003759 squared, with that 9 being significant. So we're going to put all the information for our numerator into our calculator. So we're going to go 4 times pi squared times 0.210, which should give us a value of 8.29047, with our third digit being significant. And that'll be divided by 0.003759 squared is 0.00001413, with our 3 being the significant digit in this case. And then we can go ahead and divide those two numbers. And in this case here, we should get a final value of 586,725 for acceleration. And just to round in terms of sig figs, we've got 3 sig figs in the numerator, 4 in the denominator. So our answer should have 3 sig figs, with our 7 rounding the 6 up to a 7. So our answer here will be 587,000, or in scientific notation, that's 5.87 times 10 to the 5. And our units here for acceleration are meters per second squared. So now that we found the centripetal acceleration, that is what the question asked for, so we can go ahead and write a sentence to finalize our answer here. So we can say the magnitude of the centripetal force, or centripetal acceleration, sorry, is 5.87 times 10 to the 5 meters per second squared. And then once when you have that written down, you guys have fully answered that question, so you guys are ready to move on to whatever you have next. So if you guys have any more questions, make sure to come see me in class or text me to Remind 101. And thank you guys so much for watching.